Good evening everyone. Welcome you all to the problem solving session of NPTEL course on thermodynamics. I am the TA for this course, myself Pradeev E. I am a PhD student in IIT Madras. So today we will go through the basics that is covered in the week 1 in the course, and first I will solve some problems. First I will solve the problems given in the week 0 assignment. Since it is not a graded assignment, I can solve it before the deadline of the course, but later I cannot solve the assignments before the deadline. So from the next week onwards I will solve the weekly assignments after the deadline is over. So the first problem for the week 0 assignment, I hope you can see the screen and hear me. Can you just confirm by either messaging or unmuting and talking to me? Hello, can someone of you confirm if you can hear me? Thank you for confirming. I will start with the problems. So the first question is, SI unit of work is watt, joule, pound foot, horsepower. If you know the answer, you can ping in the chat box. SI unit of work. Okay. SI unit of work is watt. The work has the unit of energy, and it can be Newton meter. Sorry, work is joules. So work energy is Newton meter or joules. The power is defined as rate of work done per time. It is either work done per time or rate of work done. So then it will take the unit of joule per second, which is watt. The area under the curve f of x 3x square plus 6x plus 9 between x equal to 1 and x equal to 3 is dash units. So to solve this problem, we take this curve y and x. So this curve could be something like this, and we have to find the area under the curve between the lines x equal to 1 and x equal to 3. So this is the area we need to find, and for this we consider y is f of x, that is 3x square plus 6x plus 9, and to find the area we have integral y into dx, that is 3x square plus 6x plus 9 into dx, that is integral. And here if you integrate individually you will have x cube plus 3x square plus 9x. Within the limits we have 1 to 3. Then we will have 3 cube minus 1 cube plus 3 into 3 square minus 1 square plus 9 into 3 minus 1. So if we solve this you will get 68. 68 is the answer. If you have any questions about the question, you can ask me. Or I can move to the next problem. Law of conservation of energy states that energy can neither be created nor be destroyed, but it can only be transferred from one form to another. So this is option 2. Mass of 300 moles or gram moles of carbon dioxide is approximately how many grams? So we know the molecular weight of carbon is carbon dioxide is 12 plus 2 into 16, so which is 44. So this is 44 gram per mole. And now we have 3000 moles, then we can find 3000 moles is 44, 3000 into 44 grams. So if you convert to kilogram, you will have 3 into 44 kg, and that is 132 kg. Do you have any doubts in this? Specific heat capacity refers to amount of thermal energy required to raise the temperature of 1 kilogram of a substance by 1 degree Celsius. So this is option 4. Newton's law of cooling states that the rate of heat loss of a body is directly proportional to the temperature differences between the body and its surrounding. It is not inversely proportional as in the second option, and it is not proportional to the square or inversely proportional to the square. So option A is right. Choose the correct relation between Celsius scale and Fahrenheit scale. This you can think of the boiling point and the melting point of water. So in degree Celsius scale, it will be the melting point of water is 0 degree Celsius and boiling point of water is 100. And in Fahrenheit scale, you will have 32 and 212. So this difference is 100 in Celsius scale and it is 180 in Fahrenheit scale. If you use these values and then try to fit in here, then you will find that option B is the right. So maybe if you put 212, you have 100 degrees Celsius and you want to find in Fahrenheit scale. So then you will multiply by 9 into 5 into 100 plus 32. Then you have 20. This is 20. So 20 into 9 is 90 plus 32. So it is 200. This is clear. In the next question we have integral dx by x over the limits x1 to x2. This is dx by x1 to x2. This we will have ln x over x1 to x2. Then we will have ln of x2 minus ln x1. This can be written as ln x2 by x1. So we have option 1. Which of the following represents total differential z? So total differential is dz can be written as dou z by dou x into dx plus dou z by dou y into dy. So dou z by dou x is from here you can write dx plus y into dx plus if you differentiate it with partially with respect to y, you will have x minus 2y into dy. Then it becomes 20x dx plus y dx plus x dy minus 2y dy. That is option. In this problem, we have to find the magnitude of the area under the curve ABCD as shown in the figure. The values of x1, x2 are given. So in a simple way, this can be found as a area of two rectangles and two triangles. So this is rectangle 1, this is rectangle 2, and this is triangle 1, and this is triangle 2. So now area of R1 is x1 to x4. Write x4 minus x1 into 1. That is x4 is 11 minus x1 is 3, y1 is 4, and we have 24. Similarly, area of R2 is x3 minus x2 into y2 minus y1. This is x3 is 10 minus x2 is 4, y2 is 7 minus y1 is 4. So this is 6 into 3. This is 80. Similarly, area of triangle 1 is half into x2 minus x1 into y2 minus y1. So x2 minus x1 is 1 and y2 minus y1 is 3. So then you have half into 1 into 3, which is 1.5. Area of triangle T2 is half into x4 minus x3 into y2 minus y1, and this is again half into x4 minus x3 is again 1, and which is the same, so 1 into 3, and it is 1.5. So if you want to add all the area, 24 plus 18 plus 1.5 plus 1.5. And this you will find it as 63. This comes to be 45. So these are the problems that were given in the week 1 assignment. Before moving to the next problems, I would just like to have some introduction about you, and little background of you, so that I can plan my problems such a way that will help you. So can someone starts by unmuting yourself and just give let us know your background, like are you from what semester you are in, or you are engineering student or what? Or you can also text in, type in the chat box. Week1, can you start?
Yes, sir.
Yeah.
My name is Week1. I'm from Ratnagiri, Maharashtra,
Okay.
and I have just completed my diploma in mechanical engineering.
Okay. And next you are trying to do bachelor's, or you will be working, or?
No, sir. I'm just trying to complete
Okay.
my BTech.
Okay. You are completing BTech.
Yeah, just now I take admission for BTech.
Oh,
I just
okay.
completed my diploma.
Okay, fine. Thank you.
Thank you.
Next person.
Hello, sir.
Yeah, hello.
I am Pawan Murli from Andhra Pradesh.
Yeah.
I am currently doing my MTech in machine design stream.
MTech in machine
Design stream.
Machine design stream. Okay.
Yeah, I have very weak knowledge in thermal side.
Okay.
So that's why I enrich my knowledge in this sector. I want to enroll this course.
Okay. Which institute you are in?
I am in JIT University, Gurupur.
Okay.
This is located in Odisha.
Okay.
Thank you.
Thank you. Next person.
Good evening, sir.
Yeah, good evening.
My name is Pradeev E. I'm from Telangana State, sir. I'm working as an assistant engineer in Telangana State Electricity Board.
Okay.
So, looking forward to complete my MTech, most probably from a prestigious institution. So that is the reason I'm joining this course.
Thank you. Next person. Jayan Kajal.
Good morning, sir.
Yeah, good evening.
Good evening, sir.
Yeah.
Sir, my name is Jayant Kajale, and I am the assistant professor in Sihagad Academy of Engineering, Kondwa, Pune.
Okay.
I had completed my MTech in thermal and fluid engineering.
Okay.
And I had opted for this thermodynamics NPTEL course.
Jude Lembo, can you give an introduction? Jude Lango, can you give an introduction of yourself? Mr. Tirupati. Dr. Anil Kumar, can you give an introduction?
Good evening, Pradeep sir.
Yeah, good evening.
This is Dr. Anil Kumar Sathe from MIT Art Design and Technology University, Pune.
Okay.
Okay. My background is I have completed my PhD in heat transfer augmentation
Okay.
in year 2021.
Okay, sir.
MTech from Thermal and Fluid Engineering from Baba Saheb Ambedkar Technological University, Lonere.
Okay.
The purpose of joining this is just for the benefit of the students.
Okay.
I have already completed 3 programs. One is thermodynamics, log of thermodynamics, where I secured something 86 marks out of 100. Then I have completed in last semester IC engine and gas turbine. I was all India topper in that particular subject from IIT Guwahati.
Okay.
Even I have completed one IC engines and gas turbine. In that also I was all India topper.
Congratulations.
Only thermodynamics I missed by hardly 1 mark. Okay. This is my 4th NPTEL program.
Okay. I think the ice engine gas turbines last year, I think last semester I also was a TA.
Yeah, probably you have taken lectures.
Yeah, something like this, problem solving session.
Yeah. I have not joined all programs, all sessions. Yeah, in last semester only, which was from IIT Guwahati.
Yes. Okay, thank you.
Okay.
Priyanka Gupta, you can give an introduction. RK.
Good evening, sir.
Yeah, good evening.
Sir, I am Priyanka Gupta. I am from Bihar. I am currently pursuing my BTech from the Ganga College of Engineering.
Okay.
I am second year student.
Okay. Are you taking this course for credit in your university or it is just out of university?
For credit purpose.
For credit.
Yes, syllabus.
Okay, thank you. RK, can you give an introduction?
Good evening, sir.
Yeah, good evening.
I am Rahul Kumar from Indore, and currently I am assistant professor in SDBC Indore, SDBC College Indore.
Okay. Thank you. Okay, thank you for your introductions. Now I just want to give a general brief outline. These problem solving sessions I will be taking live on every Tuesday at this Tuesday 6 to 8 p.m. And if there is any change, the NPTEL team will let you know through email. And you can also ask some doubts in the discussion forum that you can see in the NPTEL portal. And if you have any questions, like I will be solving some questions on which I picked from some books and which is related to that particular week course. And if you want to have some, if you want me to solve some problems also, you can mail me to this mail ID. Or you can also write in the forum, discussion forum, but that might get lost, so it is better if you have some special problem to be solved, you can mail me prior, and then I can solve in the class. And this video will be later uploaded in YouTube, and that link will also be shared to you, and also this notes in the PDF format will also be shared to you through Google Drive. The link will be available in the NPTEL portal also. Okay. And I'll move on to the problems. If you have any questions, you can ask now, or I will. Yeah, thank you, Dr. Anil Kumar. If you have any questions regarding anything that we talked earlier, you can ask now, or we can move on to the problems. So in this problem, we have a pump that discharges a liquid into a drum at a rate of some 0.0032 meter cube per second. The drum is 1.5 meter in diameter and 4.2 meters in length, and can hold 3000 kg of the liquid. Find the density of the liquid and mass flow rate of the liquid handled by the pump. So this week the problems will be of very basic in nature, and from next week onwards we will go into some in-depth problems as the course move on. So here now we see the volume flow rate. I denote it as volume flow rate. I denote as V dot, and that is 0.0032 meter cube per second, and diameter is 1.5 meters and length is 4.2 meters, and mass is 3000 kg. So using this diameter and length, we can find the volume, which is pi by 4 d square into L. So this is pi by 4 into d square is 1.5 square and L is 4.2. It is better that you also have a calculator with you and keep solving along with me. If someone of you can solve this and put the answer in the chat box, it would be great. Yeah, 7.422 meter cube is correct. And then we can find the density. Density is mass by volume. Mass, it is given as 3000 kg divided by volume is 7.422. This is 4.2 kg per meter cube. And m dot is v dot into it is you can also cross verify by putting the units on. This is meter cube per second and this is kg per meter cube, and this someone has unmuted, I think. Please unmute only when you want to talk something, otherwise please. Yeah, thank you. So if you put the units and put in the formula, then you will get to know if you are getting the right thing. So this rho is meter cube per kg per meter cube, and v dot is meter cube per second. If you multiply this, you will get kg per second, and that is the mass flow rate. And this is v dot is 0.0032 into density is 404.2. I think someone has already answered. That is correct. Thank you. I hope this problem is clear. problem, we have to convert the readings of pressure to kilopascal. Assume that the parameter reads 760 mm HT is mercury. And so the first one we have 90 centimeters of mercury. So the pressure is, we know the pressure can be written as rho into G into H. So rho is density of the fluid, G is acceleration due to gravity, and H is the height of the parametric fluid. So now for the problem A, we have mercury. So mercury's density is 13,600 into 9.81 into H is the height, and that is 90 centimeter. To write in SI units, we write 0.9 meters, and this is gauge pressure. So we have atmospheric pressure, P18, and atmospheric pressure is again given as 760 mm mercury, and that is again the same thing. So 13,600 into 9.81 into 760 mm of mercury is 0.76 meters. So we can find the absolute pressure. This also can be simplified as 13,600 into 9.81 into 0.9 plus 0.76. So P is here we will get 221,390 pascals, and then if you want to convert to kilopascal, then you will have 221.39 kilopascal. I hope Dr. Ravi is correct. In the second problem, we have a 40 centimeter mercury in vacuum column. So now P is P atmosphere minus the vacuum pressure, so that is rho GH. And for this one we had 13,600 into 9.81 into 760 mm of mercury, that is 0.76, minus again 13,600 into 9.81 into this is 40 centimeters, and that is 0.4 meters. Simplifying, we will have 13,600 into 9.81 into 0.76 minus 0.4. This is directly will get 48,003 pascals, and then this 48.03 kilopascal. So atmospheric pressure will be roughly 101 kilopascal if you put 13,600 into this one into 9.81 into 0.76, and now the absolute pressure has become less than the atmosphere, so that is what we call as vacuum pressure. Yeah, someone raise and you can.
Yes, sir.
Yeah.
Sir, actually the multiplication is there, sir. P atmosphere minus rho GH.
Yeah.
In that, the term P atmosphere and rho GH both are separate terms, sir.
Yeah. So P atmosphere. Yeah.
I have a doubt that according to the Bodmas law, BODMAS, after performing the division, multiplication, and addition, then only we finally have to perform the subtraction, sir. Right?
Yeah. Now, okay. You mean from this step to this step? This is what you are asking, right?
Yeah. Yes, sir. Yes.
Yeah. So I have taken these two terms common. We have 13,600
Yeah.
in both, no? So I have taken as common.
Yes, sir. I understood. Thank you, sir.
Any other questions?
Answer C is 113.16 kilopascal. And answer D is 310 kilopascal.
Yeah, we will solve it. C is 1.2 meters H2O. So the pressure is P atmosphere, which is 13,600. Plus, and for rho, since it is water, it has become 1000 into G is 9.81 into H is 1.2, and this is, and it is 130,600 pascals, and it can be written as 113.6 kilopascal. And next one is 3.1 bar. Here it is directly given in bar, so we have P atmosphere plus P gauge, and this is I think it's better we calculate P atmosphere earlier. P 1.4 kilopascal, and so we have 101.4 plus, or I'll write everything in pascals first, so 101.4 into 10 power 3 pascals, plus to convert the bar to pascals we have 10 power 5, so 1 bar is 10 power 5 pascals, so we have 3.1 into 10 power 5 pascals. So total we will have, if you multiply, we will get 3.1.4 kilopascal. I hope this pressure conversion is understood.
Pradeep sir,
Yeah.
In point number D, just like ABC, it has been clearly mentioned it's a gauge pressure.
Point D, it is not mentioned it is gauge pressure.
So it has to be actually mentioned. Otherwise,
yes.
it can be treated as absolute pressure also.
Yes, yeah, it can be anything. But I have considered this as gauge pressure.
Okay.
Sir, it is 411 point.
Yeah, sorry. Then it will be 4. Thank you. If there are no questions, we can move on to the next problem. 30-meter high vertical column of a fluid density 1878 kilogram per meter cube exists in a place where G is 9.65. What is the pressure at the base of the column? So again, this is simple what we have seen earlier. So GH rho is 1878 into G is 9.65 into column height is 30. So this is 543,681 pascals. 543.68 kilopascal. this is clear. The next problem, we have pressure of the steam flowing in a pipeline is measured with a mercury manometer shown in the figure. Some steam condenses into water. Estimate the steam pressure in kilopascal. Take density of mercury as 13.6 into 10 power 3 kilogram per meter cube. Density of water is this. The barometer reading is 76.1 centimeter of mercury and G is 9.806. So for such manometer problem, we will have to consider a datum, and we can consider a datum here at this point, and then equate the pressure above these levels. So we consider that this is measured at the equilibrium state. So that means the pressure above this limb and pressure above this one are equal. PA is equal to PB. So the pressure above this limb on the left hand side will be like rho GH of H2O, G and H of H2O plus pressure of steam, which is given as P directly, is equal to the pressure on the right hand side, and that is, first we will have rho of mercury plus G plus height column of the mercury plus P naught. So here P naught is atmospheric pressure and it was given as equivalent to 76.1 centimeter mercury. So now we have to find the value of P. So I have P on one side and put everything else on the other side. Then we have this term written as 13.6 into 10 power 3 into gravity is 9.806 into height of the mercury column is 50 centimeters, so that is 0.5 meters, plus P naught is the atmospheric pressure and that is 761 centimeter mercury. So then we will have again 13.6 into 10 power 3 into 9.806 into 0.761, and then this term will be on the right side, and then that becomes negative. Negative of the water column. So water density is 10 power 3 into gravity is again 9.806 into the height of the water column, which is 3 centimeters, so that is 0.03 meters. Now you can simplify this 13.6 into 10 power 3 into 9.81, so 806 into 0.5 plus 0.761 minus 10 power 3 into 9.806 into 0.03. practice to always write the values in units with units.
167.9 kilopascal.
Okay, I hope everyone has understood the problem. If not, you can ask me. If there are no questions, I will move on to the next problem.
Pradeev sir, last question.
Yeah,
Last.
before this.
This one.
Hmm.
What is the pressure at the base of the column? We are not considering atmospheric pressure from the top of that vertical column.
Yes, so
It has to be added in it, no?
yes, but yes, it has to be added, but they didn't tell anything about the atmospheric pressure, so we don't have a clue, right? So I think
Okay.
that is why they have also given 544 as an answer.
Okay, fine.
The next problem, we have a big vacuum gauge mounted on a condenser that reads 0.66 meter mercury. What is the absolute pressure in the condenser in kilopascal when the atmospheric pressure is 101.3 kilopascal? So this is P equal to P atmosphere minus rho GH. The atmosphere is 101.3, 10.3 pascals minus rho of mercury is 13,600 into G is not given, so we can take 1.81 into height of the column is 0.66. Moving on to the next problem. The basic parameter can be used to measure the height of a building. If the parameter reading at the top of and the bottom of the building are 730 and 760 mm mercury respectively, determine the height of the building assuming an average air density of 1.18 kg per meter cube. So we given a building, and at the base of the building we measure the height of the mercury column to be, say H1 is 760 mm, and when you measure at the top of the building, the height of the mercury column is 730. So the cause for this pressure change is the air that is present in the atmosphere. Right? So this air at this say this height is present. So maybe this height I take it as x, and when you measure at the bottom, you have this much of say this x height of air is also added to this pressure. But when you go to the top of the building, this air column height is not felt at the at the top of the building, and that is why you see a less pressure in the mercury column. So so based on this, we can equate the pressure difference between the mercury column and the pressure difference between the atmospheric height, pressure difference between the top and bottom, and put delta P of air is equal to delta P of the mercury column pressure measured at the mercury column. And delta P of air, we can say it is again rho GH, and that is rho is 1.18 into G is not given, so we take 9.81, and rho of the height column of air is X, that is the height of the building. And similarly, in the mercury column we have rho GH, and that is 13,600 into 9.81 into the column difference, height difference, so that is 7.76 minus 0.73, and you can calculate the excess. You can strike out the acceleration due to gravity. Then we have 13,600 by 9.18 into 0.03. And that is
345.
0.7. So that means the 30 mm mercury is equivalent to 345.7 meters of air. And that is why we saw a difference at the pressure measurement at bottom and top of the building. Do you have any questions? Consider a 1.8 meters tall man standing vertically in water and completely submerged in a pool. Determine the difference between the pressures acting at the head and at the toes of this man in kilopascals. So this is similar to the previous problem. We need to find the pressure difference between the head and the toes of the man. So that would be his height, that is 1.8. So we have delta P equal to rho G into delta H, and rho is 1000 for water into 9.81 for acceleration due to gravity, and height column is 1.8. So we can calculate the delta P. 17,658 pascals. And this is 19.66 kilopascal. This problem is clear. Move to the next problem. Consider a U-tube whose arms are open to the atmosphere. Now water is poured into the U-tube from one arm and light oil from the other. One arm contains 70 centimeter high water, while the other arm contains both fluid with an oil to water height ratio of 4. Determine the height of each fluid in the top. So now we have U-tube manometer with 2 arms, and on one side of the arm contains purely water with a height of 70 centimeters, and other side has water and oil, but the ratio between the height is given as 4. So that means this, if you consider, is x1, and this column is x2, then it's given x2 by x1 is 4. Consider from bottom, if you consider at this point, the pressure on the left side due to the left limb and the right side due to the right limb will be the same. So that we can equate, and writing pressure on the left limb, PL is rho GH, and that is, it is only water, so we have 1000 into acceleration due to gravity is 9.81 into H is 0.7. So we get a pressure for the left limb. Six eight six seven pascals. Similarly, writing pressure on the right limb, we have rho of the water, G, H, height of water, plus rho of oil, acceleration due to gravity, into height of oil. So that is 1000 into 9.81 into height of water column is x1, so I can also write x2 as 4 of x1. So that means I will have rho naught, oil rho is given as 790 into 9.81 into h naught is x2, which is 4x1. So I can write into 4x1 here. Then taking x1 as common, you will have the other terms. This is 9810 plus 790 into 9.81 into 4. This is 4089. So we have 40.09.6 x1. Now we can equate the pressure on left and right hand side. Then we will have 6 PL equal to PR. So this means 6867 is equal to 40.809.6 into x1. So x1 is 6867 divided by 40.809.6. .168 meters. So this is the height of the water column, 0.168. And similarly, if you multiply into 4, you will get the other one, which is 0.67. Do you have any questions with the problem? If there are no questions, I will move on to the next problem. The hydraulic lift in a car repair shop has an output diameter of 30 centimeters, and it is to lift cars up to 2000 kg. Determine the fluid gauge pressure that must be maintained in the reservoir. So maybe the car is lifted using a piston, hydraulic piston, and this diameter is given as 30 centimeters. And so generally there will be a piston which will lift the platform, and this piston will be put on a cylinder and connected. The cylinder will be connected to a reservoir. We want to find the pressure of this fluid. So now we know the mass is that is to be lifted is 2000 kg. So then we know the weight, which is 2000 into 9.81 newtons. And from this piston we know diameter is 0.3 meters. With this we can calculate the area as pi by 4 d square. And force on the over the piston, on the piston surface, we know the total force from the piston is pressure into area, right? And this should be equal to the weight of the vehicle. So now we have to calculate the pressure. So we can write pressure as weight by area, and weight is 2000 into by area is pi by 4 d square, which is pi by 4 into 0.3 square. Can you find what is the pressure?
Well, 28294 Pascal.
Are you sure? I am getting 277 566.
Just correct, sir. Yes, sir.
Yeah.
You are right. 277 566.
Yeah.
Excuse me, sir.
Yeah.
Sir, I have doubts. In fact, I've rolled for the thermodynamics, but the topic which you are saying is related to the fluid dynamics, sir.
Sorry.
Fluid statics. I mean, I've enrolled for the thermodynamics, sir.
Okay.
So, but the problems which you are illustrating now, which related to the fluid.
Fluid, yeah. So in the first week we only go through the basics. So I'm just going through the pressure calculation using a manometer and other stuff.
Okay, sir.
Yeah. So these are the problems you saw in the week 0 assignment, right?
Yes, sir.
Yeah, I'm just continuing with that. You are in the right class. Yeah. So just for because first week I cannot go through the in-depth topics like work heat and all, so I'm just going through some basic pressure calculations. And you can also see these problems in thermodynamics book on Central. If you don't have any questions on this problem, I can move on to the next one. Okay. Fresh water and sea water flowing in parallel horizontal pipes are connected to each other by a double U-tube manometer as shown in the figure. Determine the pressure difference between the two pipelines. Take the density of sea water at the location to be rho of 1035 kilogram per meter cube, can the air column be ignored in the analysis? So, can the air column be ignored? The column height can be ignored because the pressure difference between these points, like this and this, you can assume to be the same, because here we are talking about the pressures of this specific gravity of 13,600. And then this is of this column will have the density of 1035, and here it is of density of 1000, and these are in kg per meter cube, and here the density is around 1.1 kg per meter cube. So for simplicity we can neglect the air column and we can assume that there is some pressure inside the column, in the air column. Now to start solving, we can take this as a datum and then equate the pressure on the left side and right side of the lips. And then next we have to consider this as the datum, and then calculate that. So first solving the left side of the problem, like left hand lip, we have PL is equal to PR, and PL is the pressure of the fresh water. I write this PF plus rho GH. So the pressure of the fresh water is what we have to find. So we have to find the difference in pressure between the fresh water and the seawater. So I have PF as it is, and then rho GH is rho is 1000 into 9.81 into height of the column is 0.6. And similarly, pressure at the right of the column is some pressure of the air plus the rho GH. So PA is again unknown, and rho GH is here, the fluid is mercury, so we have 13,600 into G is 9.81 into the height is given as 0.1. 10 centimeters, which is 0.1 meters. So we have PR, which is PA plus So if you equate the left hand side and right hand side, you will find a relationship between PF and PA. So PL equal to PR, which implies PF plus 5886 is equal to PA plus 13,341.6. So you can say PF minus PA PF minus PA is 13,341.6 minus 5,086. This is 7,458.6 pascals. Similarly, on the right side, here again you can say the pressure above the limb and below the limb is same, and on the any idea how you can solve this? So consider a datum here. Pressure above and below are the same. So this is full PA, and then here on the above we have PA, and on the below we have this seawater pressure plus 40 centimeter. So the PR above is PA and PR. If you have any suggestions, you can help me, or I will solve this in the next class. Moving to the next problem, we have another system where the air pressure is measured as 80 kilopascal, and it is given to a manometer with different fluids. And first we have on the left we have water and the mercury column, and on the right side we have mercury and then oil, and we have to find this height h. Then take a datum at this point and then start solving. Now PL is P of ER plus rho GH, which is 80 kilopascal, which is 80 into 10 power 3, plus rho of water is 1000 into 9.81 into GH is 0.3. Someone solve this. 943 kilopascal, 52.5. Similarly, on the right hand side we have rho GH for mercury plus rho GH for oil. So this is 13,600 into 1.81 into height is h, which we have to find, plus for the oil the density is 720 because specific gravity is 0.72 into G is 9.81 into H is 0.75. PR is this is 13,346 into H plus
Sir, in the last problem, sir.
yeah. This one?
Yes, sir.
Yeah.
Sir, the PC water minus of rho GH will be equal to the pressure of air, sir.
Sorry. PC
You got
water.
stuck, right, sir?
Yeah, yeah. PC water.
PC water minus of rho of seawater
Yeah, yeah. Rho GH
into
of
height.
height of 40 centimeters, right?
Yes, that should be equal to the pressure exerted by the air, sir.
Equal to PA. Yeah, I think that is right. So at this point, seawater pressure is equalized by this column and the air pressure, right? Yeah, thank you for that. So then I think we can solve this. Okay, we will finish this and go. We have PC water. We have PC water minus rho of seawater, that is 1035 into 9.81 into 0.4 is equal to pressure of air. Now we have PC minus PR is equal to this value 1035 9.81 into 0.4, it is 4061.3. Now we have this equation 1 and 2. 1 minus 2 is P fresh minus PEC. It is 7455.6 minus 4061.3. So that is around 3.4 kilopascals. I hope this is clear. So for the second right limb we equate at this point. So on the right side we have only the pressure of the seawater pipeline, and on the left side we have this height column of the seawater of 40 centimeters, and then PR, that is acting on the interface. So in the next problem, like this problem can be again repeated with replacing the air with an oil of some specific gravity. Then you cannot ignore the height column of this height of the air column, or now it will become oil column. So you have to consider the 70 centimeters and 40 centimeters and then solve it, which you can try yourself, and if you have problems then you can see it in the next class. Okay, coming to this problem, we had left hand side of the left hand limb at this datum had a pressure of 82.943 pascals, and on the right side we have computed this expression. So now we have to equate PL and PR, and then we can find the value of H. So that is 82,943 is equal to 13,3416 H plus 52,97.4. It is 58 point. Directly we will get in meters, so that is 0.582 meters or 58.2 centimeters. This problem is clear. Now again it can be repeated with a gauge pressure of 40 kilopascal. So here we had 80, then if you put 40 here, then you will get a difference. The height column will be, can someone guess if the height column will become higher or lower? So currently it is 80 kilopascal and this height is 58.2 centimeters. When the pressure on the air side, that is left, instead of 80 it becomes 40 kilopascal, then the height H will be lesser or more than this?
Lesser.
Lesser. Yes, it will be lesser. Okay. The next problem, we have a double fluid manometer attached to an air pipe shown in figure. If the specific gravity of one fluid is 13.55, determine the specific gravity of the other fluid for the indicated absolute pressure of air. Take the atmospheric pressure to be 100 kilopascals. So now we can take a datum at this point. There is some issue with this application. Now if we write the pressure on the left hand side, we have rho GH of the mercury column, or it is 1, fluid 1, plus pressure of the air inside the container. So this is rho GH is 13.55 into 10.3 into acceleration due to gravity is 9.81 into height of this fluid 1 is 22 centimeters, so in SI units it is 0.22, plus pressure of the air inside the container is 76 kilopascal. So writing SI units, we have 76 into 10 power 3. So you can calculate the pressure of the left clip. Someone cross verify this. I am getting
1052 point.
Yeah, 240.
105243.
Yeah. 105.24 kilopascals. Similarly, pressure of the right limb is we have specific gravity of 2, second fluid into 1000. So this will become density of 2 into 9.81 into the column height is 0.4 centimeters, sorry 0.4 meters, plus the atmospheric pressure, which is 100 kilopascal or 100 into 10 to 3 pascals. So now we will have some in terms of SG2. 3924 into SG2 plus 100 into 10 power 3. When we equate pressure at left limb and pressure at right limb, I think someone has not moved on.
One 1.3362.
Here the answer is given as 5. I hope reading we can guess. If there are no questions in this problem, we can move on to the next one. So in this problem we have a system shown like this. The manometer two limbs have a different cross-sectional area. So one side it has a cross-sectional area of A1 and the other side it has A2. And if a change of 0.7 kilopascal, so in the air column, so delta P of 0.7 kilopascal happens, then the right side column goes down by 5 mm. And this on the right side we have a brine pipe and it's a specific gravity of 1.1, and we have to find the pressure in the brine column is always the brine pipe is always the same, and we have to determine the area ratio, that is A2 to A1. Is not very defined. So initially I would assume, for simplicity I assume that both the levels are same before the pressure change occurs. So that means with the PEA we have this column. Initially both are at the same level. And this is mercury, and then we have some water column, and then we have PEA, and on the right side we have brine. Now we can equate the pressure of the left and right limbs. PL is, we will have I will directly write, so PL equal to PR. On the PL we have rho of H2O plus gravity, acceleration due to gravity into this height. So I must consider this as x1, this is x1, plus we have the pressure of the air, which is PE, and this should be equal to, considering this column height is x2, we have rho of brine solution into G into x of brine or x2, and then the pressure at the brine pipe. The second so this I take it as equation 1. The second condition, we have reduced the air column pressure by 0.7 kilopascal. So it has become PA minus 0.7, or I would write in SI units, I would write 700 pascals. So this is PA minus 700. Then we have water column, that will be of the same height, x1, and when the pressure at this region gets lower, the air column gets lower, the mercury level on this rises and this falls by 5 mm. This falls by 5 mm, but this rises by a different distance, and that is what we need to find. So we have some some interface here, water mercury interface, and this has fallen by 5 mm to the and compared to the original case. So this is 5 mm. Now we consider, so this is mercury, and then now we consider this as a datum, and then start PLN. Equate the pressure at the left and right leg. So this was x1, it is unchanged, and now this distance has become, I would write it as x2 prime. x2 prime is x2 plus 5 mm. And earlier we didn't have any height for the mercury because we consider the datum with the level of the mercury were the same, and now it has become say x3, and this x3 will be definitely more than 5 mm, and that is what we have to find. So now equating the pressure on the left and right limb across along the datum, we have on the left hand side first we have P of mercury into acceleration due to gravity plus x3 plus this, the other things are the same, density of the water, acceleration due to gravity plus height of the water column, that is x1 plus PA is equal to, on the right side we would have rho B G. Now this x2 has become x2 plus 5 mm. To write in SI units, I would write 0.005, and this brine, the pressure of the brine pipe remains unchanged. Someone has...
Sir?
Yeah.
Sir, in the problem it has mentioned that there is a drop by 5 mm, right?
Yes, yes.
With a change of pressure of 0.7 kPa.
Yes, yes.
So the length of the column should decrease, sir, instead of increase, right? It should be x2 minus 5 mm, I hope so. Instead of x2 plus 5 mm.
So this this line drops, right? This goes down by 5 mm. Then the column of the brine column was x2 earlier. Now it will become x2 prime, which is x2 plus 5 mm.
But instead of it is dropping, it is increasing, right, sir? The length of the column.
The level of the brine, this interface goes down, but then the height of the brine column will be higher, right?
But the English sentence says it should be x2 minus 1. But anyways.
No, it only says the column drops.
Yes, the column drops means it should be x2 minus 5, right?
The pressure causes the brine mercury interface in the right column to drop by 5 mm. So this interface goes down by 5 mm. That means then I will have more height of the brine solution.
Okay. Okay, sir.
So now I have two equations. I can write equation 2 minus equation 1 and find the relation between the unknown. So now this term is new, the first term, rho h g into x3 is new, and then the second term get cancelled with the first equation, and PA is also common, goes off, and on the right hand side I have PB gravity. X2 is the same, so I will have only 0.005. Okay.
So you put the previous text.
Yeah, that's true. Yeah.
Yes.
You have some question or you are noting?
No, sir, I have to write down, sir.
Yeah. Anyway, these notes will be available to you in PDF form, so you will not worry too much about this.
Thank you, sir.
Okay, sir.
Thank you. I think someone is not unmuted. Now we know the density of mercury. Maybe they are given some value to be considered. They are given 13.56 as specific gravity. We have 13.56 into 10 power 3 into 9 power 81 into x3 is equal to we have prime solution specific gravity as 1.1 into 10 power 3 into 9.81 0.005. So now we have x3 is, we can cancel off this 10 power 3 and 9.81, then we have 1.1 into 0.005 divided by 13.56. Sorry, I think I missed the subnetted flow first as well. It was not only PA, but we had PA minus subnetted. Then we cannot, we have subnetted here. Cannot cancel it out. So x3 is what we need to find. We have prime solution is 100 into 9.81 0.005 plus 700 by 13,560 into 9.81.
Five 5.65 mm.
Yeah, 5.65. So now what has happened is so initially we had both at the same level, both the hydrogen, the mercury was at the same level, and now when we increase by 700 pascals, this has gone up by some level and this has gone down. When compared to this has gone down by 5 mm, and we say this is the datum for the second case, right? And now we saw the mercury height is 5.65 mm. So earlier it was here, now the new level is here, and this difference is 5.65 mm, and that means we have, when compared to the previous datum, we have increased by 0.65 mm, right? Because we have moved the datum also. So earlier the datum was here mentioned by black, and under we saw on the right side it dropped by 5 mm, and we consider that as a new datum. And on the left side we saw the mercury level is 5.65. So that means when compared to the original case we have increased by 0.65 mm. So that means here we have an area of A1 and here we have area of A2, cross-sectional area. Now A1 into the fluid difference level, that is 0.65, is equal to A2 into the fluid level difference on the right side, that is 5 mm. Now we can calculate the area ratio, which is A1 by A2 is 5 by 0.65. Answer is 7.6. If you have any doubts in this, you can ask now.
Can you explain, how we arrive at 0.65?
0.65, yeah. So previously this black line was the datum, right? So this was the datum in the first case.
Yes.
Yeah, and now we were told that on the right limb the level falls by 5 mm.
Yes.
Okay, and now for the second case we consider this as a datum, the red line.
Yes.
And we
Yes.
found that the mercury column on the left hand side is 5.65.
Yes.
Yeah, so
Yes.
yeah, we have moved the datum by 5 mm, but the mercury column is 5.65 mm. So that means
Yes.
0.65 mm has increased when compared to the previous datum, right? With this datum it has increased by 0.65 mm. Is it clear?
So, I'm thinking of.
Yeah, okay.
Yes.
In the second case where everything is mentioned by red, we found the equilibrium. So on the right side the mercury level was here only, and on the left side we said it is some x3, and we started solving, and when we balanced the pressure we got x3 value, and that was 5.65.
Yes.
Yeah, so that means compared to the previous datum we were the fluid level moved by 0.65 mm. So when compared to the previous datum, the new here on the left side it moved by 0.65 mm, and on the right column it moved down by 5 mm.
If that is the case, then even the height of the water should also change, right, sir?
Height of the
Water column.
water column, it will not change because there is no, we are not if you consider this one, the entire water column will move up. The entire thing is, say, x1, we consider x1, it will just move
okay,
up.
I got it, sir. As he yes. Okay, sir.
If you have questions with this problem or any other problem, you can ask now. I'm just repeating this. Video will be recorded and put on YouTube, and the link of the YouTube will be sent to you through NPTEL team. You can see in the portal on the left hand side, and also the notes will be sent to you as PDF through Google Drive, and again the link will also be sent along with the YouTube video link. And if you have next, I cannot solve any problems, any assignment problems which are before the deadline. Like if the deadline is next week and I cannot solve it now, after the deadline I can solve the assignment problems. And so if you have some special problems that you think that I have to solve, you can send to my mail ID. It's mentioned here. Have any questions?
Thank you, sir.
Yeah, thank you. If no one has questions, then I can close the meeting. Thank you everyone for joining.